Okay, let's try to figure out the interval of convergence and the radius of convergence of the following power series, which is centered at -2. So x minus a equals x plus 2 here, so a must equal -2. And we use the ratio test, taking the limit as n goes to infinity of the absolute value of an plus 1 of the absolute value of an. We're looking at the limit as n goes to infinity of the absolute value of x plus 2 to the n plus 1 over n plus 2 times 4 to the n plus 1 divided by the absolute value of x plus 2 to the n over n plus 1 times 4 to the n. And now, after cancelling the 4 to the n and the x plus 2 to the n, we're looking at the limit as n goes to infinity of the absolute value of x plus 2 times n plus 1 over n plus 2 times 4. The absolute value of x plus 2 doesn't change as n changes, so we can pull this out of the calculation, and we can also pull out the 4, and this is the absolute value of x plus 2 over 4 times the limit as n goes to infinity of n plus 1 over n plus 2. This is equal to the absolute value of x plus 2 over 4. So from our ratio test, our conclusion is that this power series converges if the absolute value of x plus 2 over 4 is less than 1, and it diverges if the absolute value of x plus 2 over 4 is greater than 1. And of course, multiplying across by 4, we get that it converges if the absolute value of x plus 2 is less than 4, and it diverges if the absolute value of x plus 2 is greater than 4. So the radius of convergence here is 4. To figure out the interval of convergence, we should check out what the interval upon which the series converges is, and also check the endpoints individually. So the absolute value of x plus 2 being less than 4 is equivalent to saying that -4 is less than x plus 2, which is less than 4, which is the same as saying that -6 is less than x, which is less than 2. And now we need to check out what happens to our series when x is -6 and x equals 2. So plugging these in individually, at x equals 2, we find that our series is equal to the sum from 0 to infinity of 2 plus 2 to the n over n plus 1 times 4 to the n. And this is the sum of 4 to the n over 4 to the n times n plus 1, so this is really just the sum of 1 over n plus 1. And of course this diverges by the limit comparison test in comparison with the harmonic series, the sum of 1 over n. When x is -6, our series becomes the sum of -6 plus 2 to the n over 4 to the n times n plus 1, and of course this is -4 to the n over 4 to the n times n plus 1, and after cancelling those 4 to the n's, this is the sum from 0 to infinity of -1 to the n over n plus 1. This is very similar to the alternating harmonic series. It converges by the alternating series test. The positive part of the terms goes to 0 as n goes to infinity, and the positive part of the terms is decreasing as n increases. So therefore our interval of convergence is the interval from -6 to 2, including -6 but not including 2.